This is going to be a theory of operation on 8mm camcorders, the mechanism, the natural loading mechanism, or what gets them to working and why they sometimes don't work. Because I've been asked a number of times about specific problems that I haven't really covered. I think going over how these things operate, what order of operation, might help clear up some of the misconceptions in diagnosing how these machines actually operate. I was asked by a viewer that was having a problem with the camera, and he was telling me that his camera, make sure it's turned on here, which it is, it won't move the tape, and it won't go down when he closes it down. So this one here is one that I use for recovering tapes because it's got no top on it. I can get at the guides to adjust the guides easily. If the tape off the camera that made the recording was out of alignment, I can get in here and I can adjust the guides. That's why this one's apart. These machines operate by sensing. There's a couple switches, first of all, that detect when the mechanism closes, and they vary by different machines, but typically on Sony's, for example, there's a little switch that gets activated when the cassette compartment is closed down. There's a little switch on Sony's. It's actually right over on this side here. I don't know where it is on this one, but we'll find it. It looks like it's right here. There's a little switch right back here. When that switch gets activated, as you can see, it loads the mechanism. And I can force it to load even without, as you saw, closing down the cassette compartment. Now I tricked it, see? When there's no tape in place, the mechanism will just close. If you've got a machine that will close when there's no tape in place, but it won't close when there is a tape in place, there's a couple things that can cause it. Usually it's the connectors at the edge on Sony that plug into the circuit board, either along the top or along the bottom, depending on whether you've got one that opened from the bottom or opened from the top. Usually it's the connectors, but there are a few other things. And I will show you what happens and how to make this machine actually go through its full loading cycle without a tape in it. Because how it knows if there's a tape in place or not has got nothing to do with switches. That was the question that was asked. Well, do these switches over here detect if there's a tape in? No, they don't. What those switches are for is they're to determine, and there's typically 2 or 3 switches in them. Regular 8 cameras usually only have 2 switches. High 8 cameras will have 3. Some only have 1. One of these switches that is activated when you put in the tape, you'll notice that there's detection holes on the bottom. And what these detection holes are there for is they are there to tell the camera what type of tape you've put in. For example, I'm going to look and see if I can find one here, because I have a high 8 tape to show you guys the difference. We'll go over the different types of tapes. Let me just grab another tape just so I can show you the 3 different types of tapes that we are dealing with. With the 8mm format, there were 3 different types of tapes that were produced. High 8, regular 8, and evaporated tapes. So they had your standard metal particle tapes, MP tape, and you had your high 8, which was metal particle, and then you had the high 8 metal E. And the camera needs to know what type of tape is loaded, and it does it through these detection switches. On all 8mm tapes, they have a record lockout switch. You can put it into save mode, which opens up this hole here, or in record enable mode, you'll see the red tab. That's detected by the furthest switch over. All cameras have that. The next 2 switches, however, are used to determine the type of tape that you're putting in. This is a regular tape. As you can see, it's got one hole here that's been punched down. Actually, is that one? I might have punched that to do high 8 on. I did. I punched that. I punched that so I could record high 8 on this, to record LP speed on digital 8, because digital 8 requires a high 8 tape. But we'll look at one that I've not intentionally punched the high 8 tab on. That was a trick. You could make a regular 8 tape become a high 8 tape by punching that tab over. And that tab is this one here. This one determines whether it's a high 8 tape or a regular 8 tape. This one I've punched through to make it a high 8 tape. So we won't look at this tape. We'll look at this tape here. This tape's a regular 8 tape that has not had the high 8 detection hole punched. Here's a high 8 metal particle tape. As you can see the difference. One has the hole punched through. And then if we look at the high 8 metal E tape, you'll see that the high 8 metal E tape, this one here, has the other one punched through. So in this case, it does not have the high 8 metal P hole punched, it has the high 8 metal E punched, which is what's determined by these other switches down here. So this camera knows whether it's a high 8 metal E or a high 8 metal P. That is what those switches are for. If these switches get dirty, it won't detect the right type of tape. And that will give you usually an error message, or the camera will not go into high 8 mode, it will only go into regular 8 mode. The question now is, how does the camera know if there's a tape loaded in it? Because obviously the only switch that gets activated is this one over here that indicates that the cassette is closed. Well, it does so by the photoelectric tape end detection system. There's a light emitting diode below here which shines an invisible ray of infrared light that hits the photo sensors on the side of the camera. There's one right here, and the other one is over here when you close it down. There they are there, you see? You can see one right there, and you can see the other one over here. So what we need to do is we need to block the light, because that is how it detects if there's actually a tape in place. When the tape is loaded. If we look through the tape itself, you'll see that there are holes in the side of the cassette on each end. And what this does is this allows the light to shine through. Now what these holes are for is tape end detection. The tape has a transparent leader. When the tape reaches the end, light can shine through from the LED, shine through that clear leader, and be detected by one of these end detectors. When there's no tape installed, obviously light is going to hit both of these sensors at the same time, and the camera knows that there's no tape installed. But when you put a tape in, light is going to be blocked by both of them. Now just a minute, you say, what if the tape is rewound to the end? Well, they're never rewound to the end, because the camera is designed, and for that matter, all VCRs more modern than, say, a VCT201 RCA, the old ones that were top loaders, that had the mechanical buttons. Everything more modern than that will automatically move the tape forward. So when it gets to the beginning, it will actually move the tape forward and advance the leader past the end detector. And all the cameras were also included in that. So what we need to do is we need to trick the camera into thinking that a tape has been put in it. And we can do that by putting a piece of tape over top of the sensor, over top of the photo sensor. So I stick a piece of tape like that, and I stick a piece of tape on the other side, and I eject it, of course. And then I load it. The camera will then go through the proper loading procedure. And the reason I'm showing you this is a good troubleshooting technique. So if I open it, you probably already saw what happened there. The motor is going to turn before it ejects. Okay, now when I close down the cassette housing, a couple things are going to happen. It's going to operate the drum motor, and it's going to operate the capstan motor, which is what turns the take-up and supply spool. As you can see, if I turn the capstan motor by hand, it turns the take-up and supply spool. So when I close it down, watch carefully. Watch the pendulum gear, watch the head drum. They are going to start to rotate as soon as I close it down. See, there it turns that, and then the drum comes on, and then it loads. There are also real sensors on here, so that it knows if the tape has moved or not. So if a tape breaks, the camera will know because one sensor won't turn. And if a sensor doesn't turn, it'll go into an emergency stop. Now, if I were to eject the tape, gotta make sure things turn here a bit so that it knows that the tape is actually moved. Otherwise, it thinks the tape might be jammed. If I, for example, were to jam the drum so that the drum can't, watch what's going to happen. It's not going to do anything. It's going to sit there, and it should try kicking the tape out again. Just like that. So if your drum stops, if I stop the capstan motor from turning, if I can hold my finger in here, same thing. And now it's going to freak out and think something's jammed. And nothing's going to happen. Now it's trying to take up any slack. But it wants to see this one turn. So it spins it long enough to hopefully retract any tape back into the cassette. If I start the loading cycle and then jam the drum, which would happen if dew or some contaminant was on here. So if I start the loading cycle, it starts spinning the drum and then I stop it. Now the camera's going to sit there. It's going to wonder what's going on, and it should eject the tape. It might not. Sony's usually will. Sony's will usually kick the tape back out, and you'll get the dew sensor or some other type of caution come up. But anyway, that's what we're getting at. If your camera is not going down, when you put a tape in, if it's not loading the tape, then something is jamming. It could be a grit of sand that's gotten into one of the teeth of the gear here. It stops the gear from turning, either the take-up or supply. It could be a take-up or supply reel that is bad. It also could be a sensor that's failed, or it could be the drum motor is not starting. And more than likely, it's going to be edge connectors. And if you turn on your Sony, for example, this was a real common problem with Sonys. You close the tape compartment and the drum spins up to a very high speed. Normally it would just turn slightly, like this, while the tape is loading. And then stop. If the drum winds up and you hear this thing winding up in speed and then it stops and kicks the tape back out, that's an indication that the frequency generator is not being detected, or the pulse generator, and that's typically the edge connector for the drum where it plugs into the circuit board has a failure. Either the connection cable is bad, more than likely it's not, though more than likely it's just the way it's seated. So that's the time when you want to pull those connectors apart and push them back on. That'll break off any corrosion or any oxidation that's on there. Anyway, I figured I would do this quick one just because somebody asked me about their camera, saying that when they try to load it, it doesn't, when they put a tape in, it doesn't do anything. You see, now if I just spin this, and normally what would happen if I just load this the normal way here, now the camera thinks that everything's good. If I eject it, and spin the spools, because it tries to rewind the tape to make sure that there's no slack, so it's looking for that sensor to turn, it will then eject. Now I should point out on Sony, now it doesn't apply to this one, although it could, but it doesn't. On the Sony, on all the Sony cameras, all the B mechanism cameras, this little flex board right here, right down at the bottom, and on the Sony it's on this side, but there's a little catch that is what's used to lock down the door. On this case, it's way back here on this camera, but on the Sony, well, this actual piece is actually more over here. The catch on a large number of the B mechanisms when they first came out on the market, it affects basically everything up to and including the DCR TRV 110. I think that's where that year is when they figured out there was a problem and they remachined it. But when the punch cut the chassis, there was a sharp edge, a little burr that stuck down on the bottom of the hook. I've done videos on it. I can't explain it on this camera because obviously it's not a Sony, but I've done many videos showing that, and what it does is it causes a scratch to occur right at the bottom here, right on the curve, and it cuts through the ribbon cable, and then you get the infamous reel detection, reel rotation sensor not turning. That's the error message that comes up. So if you get that message, look for the scratch. I've covered it in other videos. You'll have to look them up. Go look up my DCR TRV 110 chassis replacement. There's 3 parts to the video. I go over it in detail. But anyway, I just wanted to do this one quick. now I can get onto something else. I've got a ton of stuff here to work on. I just picked up something at the post office today. I've got a DAT machine I picked up the other day at the post office. I've got a Betamax. I got another camera. I got a Sony TCFX77. I got a bunch of stuff here, so I just wanted to get this one taken care of and get this one out quick, just to help you guys that are struggling with how these mechanisms operate and why it's not doing things. So you got to look at sensors, rotation sensors, edge connectors, and is something physically jamming the mechanism. And don't overlook that little white. It's a little white, I guess a retainer. It's not a washer, it's a retainer. These have a tendency to crack, and then the pinch roller can start to ride up and down. And when that happens, it'll start to chew tapes. Very common on Canon, especially their DV cameras. Very common. Canon 8mm and DV, this was terrible, but their DV cameras, a lot of them, they cracked that, and then they started chewing tapes up. And when they chewed the tapes up, they completely destroy them. You can't get any recovery off of a tape because it's basically got diagonal creases that go across a tape about every, I don't know, I think it's about every maybe centimeter or two. Anyway, it destroys the tapes completely. If I try to load a tape itself by holding it with a real tape in and hold the drum, simulating that the drum is jammed, it won't do anything. It's trying to turn the drum. That's it, right? Just like I showed without the tape in. But it'll just move the tape ever so slightly and then kick the tape out. If I jam the capstan motor, the drum is spinning now. Same thing. I think this one, in this case, it won't eject. It'll just sit there. So those are two troubleshooting techniques. If the capstan motor is jammed, it won't eject the tape. If the drum motor is jammed, it will just kick the tape back out. So that's your troubleshooting technique for 8mm camcorders, and it doesn't matter what brand, they all work the same way. If you load it down and it just kicks the tape back out, make sure the drum's turning. If the drum is turning, it's going to be a connection problem because it's not reading the frequency generator or the pulse generator. It is detecting that this is turning. And if it jams for any reason, or the camera can't read the signals produced by the FG or the pulse generator, what are part of the motor, it will eject the tape. Anyway, that's quick and easy troubleshooting. It tells you where to look. That tells you where to look on these mechanisms. And this is a Sharp. All the Sonys work the same. I'm sure all of the other brands all do exactly the same thing. I know that the Canons work the same. I'm sure all of the brands work that same way. If the drum motor doesn't turn, they're going to kick the tape back out. If the capstan motor doesn't turn, they're just going to lock up and keep the tape there until you force eject it. Thanks for watching. We'll catch you in the next one. Bye.